Everybody has their own name on their Zoom right now, which is excellent. It will really help me. Not super great with names, and so it might take me a class or two. That's why it's really great that you all have names here. Every single week when you come for a class, it would help if you come with your supplies ready. None of your supplies say that you want a towel, but it will help you if you have it. The way I have my workstation set up is I put my towel down on the table first, and then I'm going to put a big bowl on top of it. I'm going to do everything inside of the bowl. That way, in case I spill water, it keeps my computer nice and safe. Water and electricity in our computer do not mix. We do not want water on our computer. So we have to be careful, okay? To start today, we're going to play a game. This is called Science Says. It's a lot like Simon Says. So if I say Science Says something, we're going to do it. But if I don't say Science Says, we're not going to do it. So our first one will be Science Says, show me some scissors. Does everybody have scissors near them? Yep, Audrey has scissors because Cadence does. Yeah. And Dean does as well. Yes. Excellent. We all have scissors. Science Says, show me some paper towels. Yep, a regular towel will work as well, Elin. We need to be really careful with our water. So these are going to be used to clean up our mess. If we make any mess. What about if I said, show me your bag of supplies? Uh-oh, I didn't say Science Says. Science Says, show me your bag of supplies. Notice how they're labeled? They say lesson 1, so we know which bag. Yes, great job. We all have supplies. We will also have worksheets every week. So these will help us so we can do some of it in class. And if you miss class, you'll also have instructions for how to do the activities. Yeah, just wanted to make sure everybody knew that they existed. There's also some activities which I'll point out at the end of class that you can do outside of class, like after. Okay. Today we're going to be learning about density. Density is an idea of how heavy an object is, how much mass or stuff is shoved into a tiny space. Who can think of a really, really heavy small object? Does anyone know of one? Cadence does.
Sometimes rocks are heavy even though they're small.
Yeah, so rocks can be dense because they're heavy. Who else knows of something? Yes, Elin.
Maybe like a pumpkin, a small pumpkin.
Yep, pumpkins can be dense. Do we have any other ideas of dense objects? Yes, Audrey does.
Mud.
Mud. Yeah, so mud's made out of compact dirt and sometimes rocks, so it can be dense. Cadence?
Wood or dirt.
Ooh, so that's a hard one. Some wood is dense, some is not.
Right.
Yeah.
We have some heavy wood over there by Audrey. Audrey, show the wood.
What about metal? Is metal heavy? Yeah, metal's a pretty dense material as well. To start today, we are going to figure out things that are dense and not very dense. I'm going to share a PowerPoint slide with us. We're going to make predictions before we try each of them. So I here have an object. Who wants to raise their hand and share what this object is? Yes, Audrey.
A feather.
Yeah, it's a feather. We're going to use our thumbs to talk about whether we think that it's dense and it will sink, or thumbs up if we think it will float. It's really buoyant. So I see Audrey, Dean, Cadence, and Elin all think it will float. Do we want to try? Yeah. So we're going to pour some of our water into a glass. And we are going to try to float our feather. We are going to observe what happens when we put our feather into our glass of water. And we're going to raise our hands so we can share our observations. Who notices what's going on inside their glass? Okay, we're going to share our observations. Who wants to raise their hand and share? Elin?
It's like floating.
Ooh, so you observe it does float. We all gave a thumbs up saying we thought it would float. So that was our prediction. When we put our feather in the water, we made an observation that it does float. We were correct. Yes, Cadence, you want to share?
Yeah, even if you push the feather into the water, even though it has water on it, it will still float the same amount.
Yes. This is because a feather is really light. It's actually buoyant. Buoyant is a term that means something will float. That happens when an object is not very dense. I have another object we can try. This is a paper clip. Let's use our fingers to make our predictions. Do we think it's going to float or sink? Ooh, I see we have a split vote here. So Audrey thinks it will float and everybody else thinks it will sink. I wonder who's correct in their prediction. Let's do our experiment. We're going to take one of the paper clips out of our cup. We're going to put it inside the cup and observe what happens. What do we see? Hey, Dean, do you see your paper clip floating or sinking?
I see my paper clip sinking.
Yes, it sinks. Who knows whether this means that our paper clip is dense or if it's not very dense? Audrey does? Do you want to share with us?
It's dense.
Yes, it's dense. It sank to the bottom of our glass instead of floating. Great job, everybody. This is a marble. While we don't have a marble in our bag, we can still make a prediction about it. We've already learned about some objects that sink and float. So what would be our prediction about a marble? Do we think it would float or sink? So a marble is really dense. It's heavy, even though it's small. So it would sink. Great job, everybody. We have a screw. This is also made out of metal. Do we think it would float or sink? Yeah, I see a lot of us think it would sink. That would mean it's really dense. We can make this prediction based on what we already know. So we know that it's made out of metal, just like our paper clips were. And our paper clips sank. So this big, dense metal object would also sink. We have a bolt inside of our bag of supplies. So I think you guys have a nut. Do we think our nut is going to float or sink? Ooh, I see that we think it's gonna sink. Let's try. We're gonna put it in our glass. We're going to observe what happens. Elin wants to share her observations.
When I like placed it in, it like went like straight down.
Yeah. So what does that mean about how dense it is? Is our nut dense or is it not very dense? Cadence wants to share. You want to unmute yourself?
Dense.
Yes. So dense things sink. Excellent. And our feather, was that dense or was it not very dense? Dean, you're raising your hand? Or were your hands just in front of your screen?
I was raising my hand.
Yeah, did you want to share?
So a feather's not very dense.
Yes, great job, thank you. So our feather was buoyant. It's not very dense and it floated. Did you know that liquids can also be dense or non-dense? So some liquids will float on top of other liquids. I'm going to show everybody an example. So I put some water and food dye inside of a cup, and I have some olive oil. What do you think is going to happen when I pour my olive oil into my cup? Oh, Cadence, you think it's going to sink? Elin, what do you think? You think it's also going to sink? Dean thinks it's going to sink and Audrey does too? Let's see. So my olive oil was the yellow liquid. It's not sinking. It's floating on top of the glass. Can everybody see that? Yeah, olive oil is less dense than the water. It's really buoyant, so it floats. It also doesn't want to mix with the water. We could do this with all kinds of liquids. Every single liquid has its own amount of density. That means every single one will either float or sink more than others. There's someone else who did this experiment for us. We can see all the layers of our liquids here. Down at the very bottom, we have something that is the most dense. And up at the very top, we have something that is the least dense. It's the most buoyant up here at the top. Does anyone want to share what they have seen? Yes, Cadence.
When it sinks, that means it's less dense, which means that oil's not dense.
Ooh, so when it sinks, it's very dense. And we saw that our oil did not sink, so it's less dense than our water. Does anyone else want to talk about what they just learned about density? Audrey?
That the density is was heavy than the water.
Yes, things that are really dense are really heavy. Great job, Audrey. Did anyone want to share anything else before we move on? No? Okay. We're going to move on to our next experiment now. What we are going to need is our bottle. We are going to need our glass of water and our funnel. We are also going to need our pipette, our nut, we always want to have our paper towels close to us. And we're going to want our scissors. What we are going to want to do first is fill up our bottle of water pretty close to the top. You can use your funnel to make sure that the water goes in. So my bottle is almost all the way full. Excellent. I see we all have a bottle with water in it. We need to be very careful because that's a lot of water. We do not want to spill it on our computer. So we're going to put it far away from us where we won't accidentally hit it. We can also put the cap on it for now. We are now going to need to pick up our pipette. A pipette is a tool that scientists use to pick up fluids. We are going to try it for a second. So how we use a pipette is we squeeze the top, we stick it into our liquid, and we let go of the top. It'll suck up whatever the liquid is. When we squeeze the top again, out comes our liquid. Yeah. We are going to use our pipette to make our Cartesian diver. So this is going to represent how a scuba diver can get to the bottom of the ocean. We're going to use the fact that our pipette can pick up liquid to do this. So remember, it picks up liquid whenever you squeeze the top. We are going to call the top part that we squeeze the bulb. We're going to call this big bottom long part the stem. We now need to look really closely at our pipette. We have a little line down at the start of our stem, right here. You can see the lines on your pipette. Can everybody find their first line on the pipette? We need to cut our pipette on that line. Yeah. Excellent. We're going to make a prediction about the bulb of our pipette. Who thinks that it's going to float? Who thinks it's going to sink? Let's use our fingers. Ooh. We all think it's going to float. We are going to drop it into our water. What do we observe? Yes, Elin?
It floats.
It floats. Is it buoyant?
No.
Boats are buoyant. They float. Yeah, it's buoyant. It's not very dense. It floats. That's because it has air inside. Air is really light and buoyant and not very dense. How do you think we can get our pipette bulb to sink? Elin, what's your idea?
Maybe we can like screw the screw on here, like kind of like that.
That might work. Then it would be heavier and have parts that are more dense. Cadence, what's your idea?
Put the nail into this piece.
Ooh, so you're also adding a heavy, dense object to it.
Oh, it just came right out.
Yeah. Yeah, so we can try that. We can put our bolt or our nut onto our pipette bulb. So we are putting our nut onto the end of our pipette bulb.
How about like this?
Yeah. Let's put it into our glass and see what happens.
Sink and sink. Sink.
Does it all sink? Who wants to share their observations? Audrey, yes.
It almost all of it floated.
Ooh, so parts of our new Cartesian diver float, but not all of it. Dean, did you want to share something? Okay. Who knows what part is floating? Which part is sinking? Elin, yes. Do you want to share?
The part with the metal in it is like sinking, and then the rest is floating.
Yes. Does anyone have any guesses on why that's happening? Yes, Elin.
Because the metal is more heavy than the air, so then it drags it down, but not all of it, because it's not all around in it.
Great job, Elin. Yeah. So our metal is the most dense part of our Cartesian diver. And the air up at the top is the least dense. So our air is floating while our metal is sinking. That's why it sits somewhere in the center of your water. Yeah. What about if we want it to go all the way to the bottom of the glass? Who has an idea how we could do that? Cadence, what is your idea?
What if we attach the paper clips to the screw and then we attach another paper clip to the tube? That would work, probably.
Mm-hmm. Do we want to test Cadence's idea? So she's saying that we could put one of our paper clips on our bolt. And this would help it so it could sink.
Screw.
What happens if we put our paper clip onto our nut? Does it sink? Audrey, what do you observe? Does your entire Cartesian diver sink? Or is part of it still floating?
Part of it is still floating.
Ah, yeah. We have to try something new. What about if we were to take our paper clip back off of our nut? We were to stick the whole thing in our glass and we were to squeeze so some of the air comes out. So we're sticking it all in our glass. We're squeezing our pipette bulb. And we're going to notice what happens. Can we get our Cartesian diver to sink by putting more water in? Yes, Audrey, you want to share?
So it got more in the water.
Yeah, we could make it so it sank more. That's because we removed the air from inside of our pipette bulb. The air that was really buoyant and wanted to float is no longer in there. Okay, we're gonna try one more thing. Our challenge is to get our Cartesian diver to just barely float. So we just barely want it not to sit on the bottom of our glass. So we can adjust the amount of air and water that's inside of the bulb. So we don't want it to sit on the bottom. We want it to barely float. When you get yours to barely float, please raise your hand to tell us that you completed the challenge. Dean did? Excellent. Audrey did? Great job. Want to see if anybody else can complete the challenge as well? So we're just going to wait for a little bit longer to see if Cadence and Elin can complete our challenge. Cadence has also completed the challenge. Wow, great job. This is going to be part of our Cartesian diver in a bottle. So once we get it to just barely float, we're going to move on to our next step. Elin, have you got yours to barely float?
Will it like still be floating, but like barely?
Yeah.
But there's still the bolt on, so it will like still go down.
Yeah, we just don't want it to sit at the bottom of the glass.
Yeah,
Like just barely float above it.
Yeah, so it's just barely in the center of our glass, moving along. Did anyone?
this.
Yeah, that'll work. Okay. Does everybody's nut stay on their Cartesian diver? Has anyone had an issue where it fell off? Okay. Oh, Elin, you have had an issue where it fell off? Okay. If your nut falls off, what we're going to do is we're going to take a piece of tape. We're going to wrap it around the base, around our stem and bulb. We're going to stick our nut back on so it's a little bit tighter. And then we're going to tape around our nut.
I need to go get tape real quick.
Okay, yes, Cadence.
Or if you don't use tape, you can use a paper clip to hold it on.
It's going to be hard to get into your bottle if you use the paper clips. Yeah. That's why we're going to use tape. We're going to give Elin just a little bit longer to get back. That way we don't start the next part of our experiment without her. So our Cartesian diver is going to represent how divers in the ocean can get to the bottom of the ocean. Humans are buoyant in the ocean. That means they float a little bit. In order for a diver to get to the bottom of the ocean, they put on metal on themselves. They make themselves more dense so they can sink. These are called weight belts. A diver also has a lot of air that they bring down so they can breathe when they're under the ocean. What did we see about the air in our pipette bulb? Did it help so it sunk, or did it help it float? Cadence? Yes, what did the air do?
It helped it float, and I found a solution with the paper clip.
Yeah?
You put the paper clip in the pipette piece, and then you can put it in the water. You just
Okay.
have enough water.
Yeah, so you're changing our experiment. That is okay. Did you know that after this class, you can change the experiments in any way you want, as long as you ask your parents? Yeah. I'll give you guys suggestions of how to play with them after as well. So we are making a Cartesian diver, though we can learn about how a diver goes down to the bottom of the ocean. So we have our pipette bulb that's filled with a little bit of water, so it floated part of the way. Audrey, you're raising your hand?
divers sink is because we're heavy.
Ooh. So a diver actually has to put metal on themselves in order to sink. If you were to go in the ocean, you would not go all the way to the bottom of the ocean with your lungs filled with air. You would float a little bit. You're buoyant. We are going to put our Cartesian diver into our bottle of water. We're going to put the cap onto the bottle. We want to make sure that our cap is screwed on nice and tight. When your cap is screwed on, we can squeeze it and we can tip it around. We can watch what happens. We can change where our diver floats inside of our bottle by how much we squeeze it. By squeezing it, we are forcing more of the water into our pipette bulb. Can we make whirlwinds in there? Yeah. We can see that the water is moving in waves inside of our bottle, and it forces our diver to move as well. Cadence, you are raising your hand. You want to share?
Is it just like a hurricane when you twist it around and then flip it upside down?
Yes. Hurricanes are when the air moves around and around. Sometimes it moves water as well. So we're going to play with our diver for a little bit longer. We're going to see what we can make it do. Can you get your diver to sink more? Can you get it to float more? Let's try. We're going to spend a couple more minutes playing with our diver now. Yes, Elin.
Can I add some food dye to it?
Yep, that's what our next step is. Yep, if you have food dye, you can drop probably only about 2 drops into the bottle. You can watch where the food dye goes. Do you think the food dye is going to float or sink? Audrey thinks it's going to float. We can try. Elin, what are you observing? Does your food dye float or does it sink?
It sinks.
It
It's like
sinks.
sinking slowly.
Yeah. That Cadence? Well, you're raising your hand?
The food dye will sink.
Yeah, it does sink. Elin is
I did it.
showing us. So she's dropping the food dye up at the top of her bottle. And it
Can I have
slowly goes down.
You're not doing this.
Not doing it over the top. Yeah, I'm putting 2 drops in.
We can also watch really closely as our parent or ourselves drop our food dye in. Do we see how it spreads out in our water? Yeah, that's called dispersion. So all the color wants to slowly spread out. We can shake it up and we can force it to spread out even quicker. Yeah, I see Cadence has a blue liquid in there. Elin also has blue. Dean has orange. Ooh, Audrey's mixing colors in her bottle. Did you know that the reason why it looks bluish underneath the water in the ocean is because the water acts as a big filter of light? Yeah, so it fools our eyes. Not everything under the ocean is blue. It's just because not all the light of different colors gets to our eyes. Cadence, you're raising your hand via Zoom? You're just playing with buttons? Okay,
I accidentally hit the button to raise my hand.
that is okay. So we're gonna play with our diver for a little bit longer. And I'm gonna show us another experiment. Yes, Audrey.
So the Cartesian diver, it sank.
Ooh. So we can force it to sink and float by how much water is inside of our pipette bulb. We can squeeze our bottle and force more water inside of our diver. Okay, we're gonna spend only about 30 more seconds playing with our diver and making observations before we move on. Does anyone have any last observations that they want to share about their diver? No? Okay. I'm going to share with all of us another experiment using density. Let me share my screen for you. So this man here is going to do an experiment for us using the density of soda pop. Let's watch really closely and see what happens.
So it's a little easier to see. So students can make some observations and predictions about whether it's going to sink or float, and then we'll see what happens. So we have our regular soda. We'll make a prediction. Is it going to sink? Is it going to float?
What do we think is going to happen? Do we think our regular soda is going to sink? Thumbs down. Or is it going to float? Thumbs up. Ooh, we have about a 50-50 split. Half of us think it's going to sink. Half of us think it's going to float. So we now have to observe really carefully to see whether our prediction is actually true.
We put it down in the water and it sinks to the bottom. So now,
Ooh, so our regular soda pop sinks. We also have another bottle of soda. This is diet soda with not as much sugar in it. Do we think that our diet soda is going to float? Thumbs up. Or sink? Thumbs down. Oh, Ellen thinks it's going to float. Audrey thinks it's going to sink. What about Cadence and Dean? What is your prediction? Dean thinks it's going to float. And Cadence thinks it's going to sink. Ooh, let's see what happens.
The students start to build a little bit of knowledge. So this time we'll try the diet soda. Same volume, probably same amount of soda inside of the can. They just saw the regular soda sink, so they can make a prediction again. Does it sink or does it float? Drop the diet soda down in there, and
it floats. So we saw that just the difference of how much sugar is in our soda changes the buoyancy, changes how dense our soda pop is. So our regular soda sank and our diet soda floated. Which one was more dense? Yes, Audrey, which one was more dense?
The regular one.
Yes, the regular soda was more dense than water, and it was also more dense than our diet soda pop. This is because of the amount of sugar that's in there. Sugar is heavy. Who here has ever lifted a bag of sugar? Yeah, it's really heavy. It's really dense. A regular soda pop has a lot of sugar in it. Has a lot of dense material. It's heavy, so it sinks. We're going to look at what's left in our bag of supplies for today. We have some rocks. We're going to make a prediction about what will happen with our rocks. Who thinks it's going to float? Who thinks it's going to sink? Oh, we all think it's going to sink? We are going to use our glass of water, and we are going to test our prediction. We can drop some of our rocks into our glass of water. So I'm dropping my rocks into my glass of water. What do you observe? What do you see? Yes, Cadence, what do you observe?
It sinks.
Our rocks sink?
Yeah.
Ooh. Who knows what this means in terms of density? Are our rocks more dense than water, or are they less dense than water?
They're more dense.
Yeah, they're more dense. Thank you, Cadence. Audrey, you're telling me that your rocks sink as well? Yeah, that makes all of our rocks sink. That's really good because they're all the same type of rocks. They should all sink. We have 2 balls in our bag. Let's feel how heavy they are. Who thinks that these are really, really dense and heavy? Does anyone think they're dense and heavy? They're not. Oh, great. What do we think is going to happen when we put them in the water? Thumbs up, float. Thumbs down, sink. Cadence thinks they're going to sink. Audrey thinks they're going to float. Dean thinks they're going to float. Elin thinks they're also going to float. Let's drop our big ball into our water. Huh, it does float. What about our tiny ball? Let's drop it into the water. Yes, Audrey, you want to share?
It floated.
It does float. Does this mean that they're buoyant? Thumbs up if they're buoyant. Yeah, they're very buoyant. They float. Excellent. Cadence, you want to share?
They're like ice cubes.
Ooh, yes. Ice cubes also float. They're more buoyant than water. That's because there's air trapped inside of your ice cubes. That's also why ice cubes look sort of whitish. We know that air was buoyant and it floated. It was not very dense. That's what makes our ice cubes also so they float. We also have a popsicle stick. Let's make a prediction. Do we think it's going to float or sink? Oh, Elin, is that a you don't know, or is it a you think it's going to float somewhere in the middle of your glass?
I think it's going to like float like somewhere in the middle of the glass.
Ooh, that's an interesting prediction. Do we want to test it? Let's trust it. We're going to drop our popsicle stick into our glass. Yes, Cadence, what do you see?
It floats.
Yeah, it's not touching the bottom of my glass. It does float a little bit. Audrey, what were you observing?
I was observing that it sank. No, it floated.
Ooh, yeah, so we see at least part of it's floating. Does the whole popsicle stick float above the water?
Mm-hmm.
All of it? So there's none of your popsicle stick that goes below the water? I see at least part of it below my water. So here's the line of my water. There's part of my popsicle stick down there.
It's because it's too tiny. It's too tight at the all of the thing. So mine is actually floating because I'm in something a bit bigger.
Okay. Can we make our popsicle stick sink? Cadence
Yes.
has an idea. Let's all plan for 1 minute how we can get our popsicle stick to sink. Audrey, you have an idea that you want to share?
Got it.
If we put like one of the paper clips on it, then it might be able to sink.
Ooh. So Audrey, you can test that. You can put your paper clip on and see whether it sinks.
Or you could put your paper clip on and a penny on, and then drop it in, and it will sink right away.
Ooh. So Cadence adds more mass and it sinks. Yes, Audrey.
It sank.
Yeah, great job. We can try this from objects around our house as well. Let's see what we have. Does anyone have any different types of rocks around them?
Yes, I
Yeah.
can try and do something with that.
We could also use marbles or Legos or coins. So we're going to take 2 minutes and see if we can find something that will float and something that will sink. Ooh, I think Elin's going to make us something. Dean found something that floats. Oh, Elin, what have you found or made?
I put like the strap of like the Q-tip and like taped it together, and it's like sinking. And then when you put the ball thing like at the end, then it will float.
Ooh, great job, Elin. So Elin modified her popsicle stick. When she put the styrofoam ball on it, it floats. And when we put the other part of our pipette on, it sinks because all the tape that holds it on is really dense and heavy. Cadence, what did you find?
If I attach my rock to my pickle stick with something, right now I'm using a Wiki stick, then it will sink right away.
Ooh. So our rock is our really dense object, so it will sink. Great job. What else did we find? I saw Dean had something that floated.
I'm gonna see what
Yeah, a rubber ducky floats. That's because it's filled with air, and the air is really, really light and buoyant. Great job, Dean. And Audrey, what did you find?
focus on her.
So I found that if you have the rock in the water and you attach the leaf to it with tape, then it might, I learned that it could float still.
Ooh. Is the whole rock and leaf floating, or is it only the leaf?
The leaf.
Oh, yeah. So our leaf has a lot of surface area. That's going to help it so it can float on top of the water. Just like a boat. Takes up a lot of space over the top of the water. We're going to learn about surface tension later in class. That is how the boat can stay on top of the water by spreading out all of its mass over a large area. Even though it's made out of metal. Metal normally sinks, but a boat can float. Yeah. So we have 2 minutes left of class. I want to remind you guys that your worksheets have more fun activities you can do. They will all be related to buoyancy and density for today. I would suggest you try them. They're pretty fun. We learned about buoyancy and density today. So we saw that air was really light, and so it was really buoyant and not very dense, so it floated. And I see that a lot of us practice with rocks, and they sank. They were really dense. Who else wants to share about one thing that they learned today or observed? Elin.
That like if you like fill like it with water, then it will like sink, and if it like not filled with water, then it will like float.
Yeah. So that's because water will have the same density as other water, but air is less dense than water, so it floats. Who else wants to share something that they learned or observed today? No? Okay. I'll leave you guys with a thought here then. Density doesn't have to only be inside of a liquid. Things can be floating in air. A helium balloon floats, wants to go up into the sky. That's because it's less dense than the air that we breathe. Thank you guys for doing science with me. And next Wednesday, we will come back at the same time to continue doing science. We all have our supplies ready for coming to class, then we can continue. We can start right on time, okay? I'll see you guys next week. Bye.